Hello, Math 7 students. Today I want to talk to you about perimeters and areas of similar figures. So when two figures are similar, the value of the ratio of their perimeters is equal to the value of the ratio of their corresponding side lengths. And you say, I say, well, consider this triangle ABC and triangle DEF. Let's say they are similar triangles, all right? Then the perimeter of ABC over the perimeter of DEF, that ratio will be the same as the ratio of side AB to side DE, and that will be the same as the ratio of side BC to side EF, and that will also be the same as the ratio between side AC and DF. Okay, so those ratios are all the same. Now for areas of similar figures, when two figures are similar, the value of the ratio of their areas is equal to the square of the value of the ratio of their corresponding side lengths. So if you have the area of triangle ABC over the area of triangle DEF, that ratio is equal to AB over DE squared, which is also equal to the length of BC over the length of EF, the quantity squared, and AC over DEF squared. Right, so for areas, you have to square the ratio. Let's look at an example. Find the value of the ratio, large to small, of the perimeters of the similar trapezoids. So they only give us one side length, and so they want us to do the ratio of the perimeters. So that would be the same as the ratio of the corresponding sides. In this case, it's 21 to 15. We know that that can be simplified, right? 21 and 15 are both divisible by 3, so we divide them both by 3, and we get 7/5. And that's the ratio of the perimeters. Let's look at the ratio of the areas. Find the value of the ratio, large to small, of the areas of the similar parallelograms. And so they give us corresponding sides. One is length 9, one is length 6. And if we want to find the ratio of the areas, we make a fraction, right? Large to small, so large goes on top. So it'd be 9 over 6, but then we need to square it and simplify it. So we square the top. 9 squared is 81. 6 squared is 36. And then we can simplify that, right? We can divide both the 81 and the 36 by 9, and it simplifies to 9/4. There we go. And then question 3 refers to an example in your textbook. And so I have drawn the pictures from the textbook. They say the width of the pool is now 22 yards. Find the perimeter P and the area A of the pool. Well, there's this like tennis court, right, that is a similar rectangle to the pool. And so the perimeter of the court over the perimeter of the pool, that ratio is equal to the width of the court over the width of the pool. And so, well, what's the perimeter of the court? They tell us the perimeter is 60 yards, so we would put that there. The perimeter of the pool is what we're looking for, so that is P. The width of the court is 10. They tell us that there. And the width of the pool is 22. So that goes right there. So we have this proportion, 60 over P equals 10 over 22. So we would cross multiply. We get 10P equals 1320 or 1,320, right? And we would divide both sides by 10 and we solve for P. P is 132 yards. So that's the perimeter of the pool. Then we need to find the area of the pool. And there's more than one way to find the area of the pool once you have the perimeter. But we're going to use what this lesson is about and use the ratios and the proportions. So the area of the court over the area of the pool is equal to the square, right, of the width of the court over the width of the pool. So what's the area of the court? It is 200 yards squared. Over the area of the pool, that's what we're trying to find, is equal to, well, the width of the court is still 10. The width of the pool is still 22. But then we need to square that, all right? So we first square it, and we get 100 over 484. Then we cross multiply, and we get 96,800 equals 100A. Divide both sides by 100, and you get A equals 968 yards squared. And that's how we find the area of the pool. I hope this video is helpful as you look at your homework for tonight. Make sure to show your work and do your best. We'll see you next time.